Just checking if the stream is live. Yeah, I got the green light. So today's stream, we're going to be talking about feedback loops and how feedback loops can be used to improve your web development, your programming skills. So I just going to grab a drink for a mo. Bear with me a minute. So feedback loops, we all have feedback loops in our lives. There are so many different types of feedback loops that you can have in both psychology and in anything that initiates a response, in the sense that you can analyze that response. It is feedback of something that you've done that can be repeatable. That is essentially what a feedback loop is in a nutshell. So I'm going to be talking about that and how you can improve feedback loops, or improve yourself as a programmer by choosing the right feedback loops. I'll be talking about that in just a second. Now, first of all, before we get into any of that, I just want to say a massive thank you to all of the new subscribers coming on. Hello, welcome. My name's Peter Fisher. I'm a freelance web and mobile applications developer. I do 3 shows on YouTube a week. The first one is a Tuesday. That is a tutorial. And we've been covering a Python control structures course. And I think we're on the 9th tutorial. The one that was on this Tuesday was all about if and else statements. So if you're learning Python, then do think about subscribing and just start learning Python. I also do all sorts of things like PHP and Linux and all sorts of other jazz. So check all those out too. The Wednesday, which is obviously today, is a live stream where I'm going to choose a particular topic. And in today's topic, it is feedback loops, and then I'll be just talking about it live, off the cuff. On the Friday show, we do there's like a pre-recorded episode. This Friday, I'm going to be talking about the controversies of the Linux code of conduct and all of those kind of things. So if you're interested in Linux, then do subscribe to pick that up too. Now, this Wednesday show used to be the Web Developers Working Week thing, where I would talk about what I would get up to as a freelance web developer. This week has been relatively DevOps related, pretty much similar to last week, in the sense that I've been configuring a lot of Lambda scripts on AWS. I've been just doing a lot of trial and error with bucket policies on AWS. I've been writing a lot of API endpoints in PHP, and I've been doing an awful lot of Node.js using ES6, and going through the different promises and communicating with various different pieces of architecture in AWS. So S3, SQS, and Cloud Watch, and all of that other jazz, all of that good other stuff, through a Symfony command. So I'm a Symfony developer, or at least some of the projects that I'm working on are Symfony based in PHP. So I have been writing Symfony commands to then do stuff in the cloud with the AWS infrastructure. It has been very DevOpsy. There's been a lot of configuration this week, and there's been a lot of things that just still aren't working that I need to get through and get working. But that's basically been my week. There has been a lot of change to the howtocodewell.net website. Lots of change. I did all of this last weekend. And now we have a blog section where you can actually go through all of my previous. I think what I've set it to is mostly the Friday show. So all of the pre-recorded stuff you can go through. There's 122 videos available on the howtocodewell.net /blog part. So if you do ever miss anything, that if you are subscribed and you do miss anything, then you can use that as a way of just watching some more of my content. Also, I've been pushing stuff to Instagram and Twitter more. So if you're in those social media spaces, then do subscribe and follow me there too, just in case you don't get anything from the old YouTube algorithm that seems to be changing left, right, and center. So that's basically been my week in a nutshell. Just quite busy, lots of DevOpsy type stuff. I can't wait until I can actually say that this week has purely been coding. It seems like, well, I can't remember the last time it was purely coding. There's been all sorts of, like today, I was building a Docker container to mimic the AWS Lambda scripts. And it got to the point where I had a Docker container running and I was thinking, why do I need to have Lambda? Because we have this container running. That containers are supposed to be ephemeral in nature. They're supposed to be torn down and brought back up to life. Not the same container is never the same, that kind of thing. And I was kind of like in that sort of fork in the road, and it's like, well, I've built something to test locally that I could just put in production, which overrides the need of the Lambda stuff. Some of the bits and pieces, though, that I am doing will require Lambda just because of various constraints on the projects and so forth. So there is obviously that, but it's very tricky to test locally a Lambda script without the need of using Docker. Because, well, the things that I was doing was manipulating images, and in order for that to work, the libraries needed to be compiled to meet the specification of the host machine. And of course, the host machine in the serverless world is just literally someone else's server, right? So you need to have a Docker container that kind of mimics that. It's very similar to that. And you can't just run it locally on your local machine, which in my case is OS X, because that's totally different to what you have in the cloud. But anyway, whatever. Feedback loops. Let's talk about feedback loops. So hello everyone who's joining. Hello Jayish. Thanks ever so much for joining. You've asked a question already. Feedback loops means alter software deployment / release in the market. Okay. So I mentioned earlier in my intro bumble that feedback loops are a part of life. We, as human beings, we desire feedback loops from different mechanisms. So, for example, if you put out a post on social media, you're putting out a post on social media because you would like to you want to get a response back, whether that's being a like, whether that's a follow, whether that's something. It's not just something that you just put out as noise and it just gets forgotten about. You want to drive traffic to something, or you emit an emotional response based on the feedback. So if someone is having a go at you on social media, that's going to make you feel sad, right? But if someone is approving what you've done, that's going to make you feel happy. That is a feedback. And because it's you can say it's in a loop, because you can do that again and again and again. And this is the same with anything in biology, in psychology. There is so many feedback loops that we use without even thinking about. Now, with programming, the feedback loops can be very, very small, or they can be extremely large. So yes, when JS has said feedback loops means after the software is deployed, released to the market, and then discover what the market thinks about your stuff. So yes, but from a software development point of view, when you're actually developing the software, you want to debug that software, and therefore you want to get to the actual specific part of that has a bug. What Jayesh was talking about there is actually, once it has been deployed, getting feedback from those who use it. And yes, that is obviously a feedback loop, but let's go a little bit granular than that. Let's talk about the actual feedback loop when you're actually coding these things. Now, often a challenge that junior developers get is, they write some piece of lovely code and then they put it on the page. Let's say, for example, for argument's sake, they're a JavaScript developer, and they don't know why whatever they've built doesn't work. So they keep refreshing the page and it doesn't work. Well, if they don't have a way of having any feedback to tell them how the system is actually processing, then it's very tricky to understand where there is an issue in the program. Same with PHP developers. So how many times have you, as a PHP developer, refreshed the page and you just get a white blank screen of doom? You know, I have several times. I've refreshed the page. It's hit an internal server error, which is a 500 error. I get a white page of doom. There is zero feedback in that. However, there is certainly feedback that is being produced in the log files. So part of using feedback as a way of improving yourself as a developer is knowing where the feedback is actually being stored. So usually feedback gets stored in standard output or standard error. So if you've done my Linux Bash for Beginners course, there's a portion there of how you can actually manipulate where those streams actually go. So if you're working on the command line, you can tell that or do whatever you want with that stream. But essentially, whenever you get a white screen, something gets added to a log file, and that log file is usually, if it's say Apache, it's in the Apache log file. If it's in Nginx, it's in the Nginx log file. If it's a Red Hat or a CentOS box, then it's in that specific place. So you need to know where that feedback is going. And one thing, I mean, I'm a Linux dev, right? So one thing I like doing, and because I use Docker pretty much all the time, is I like having a terminal window open where I'm tailing and following the logs. So when I'm doing something on the application, I can actually see how it's being processed in the logs. So that's knowing where the log files are. So that's basically point A of using feedback loops in a way that makes you a better developer. The next point is how you can actually manipulate the log files. So for example, as a Symfony developer, there are various ways that you can use things like Monologue, which is a Symfony component that allows you to write to the log files. And again, if you were a JavaScript developer, you might be using something like console.log. So that's actually logging stuff, physical stuff, to something that you can see the response and you can act upon that response. Okay. So feedback loops also allow us to track changes over a period of time. So this might be some form of analytics. This might be some form of metrics that you are tracking, how many registered users get to your system. So now I'm talking about where a system is in place and you want to measure the progress or the success rate of something that you've put in deployment, that you've deployed. So feedback loops isn't just about writing on the code. It's also knowing the system. You don't actually know, you've written the system, but you don't actually know how that system is going to be used by the user until you can actually record what the user is doing. Again, when you get a HTTP request, that usually goes into the access log. So knowing where the access log is. Usually when you're playing with web server, you have an error log and an access log. So an access log will tell you what request has come in to what location by, I think, what IP. So you'll be able to find out what status code is coming back at a particular page. So for example, in the access log, you've got you'll have different status codes depending on how that response was created or was returned. So if it's a 404, then that request cannot be fulfilled because that request that destination doesn't exist. If it's a 500, it means that yes, that destination does exist. However, the whatever has been processed upon that request, it's blown up in a cloud of smoke, and it's returned a 500 internal server error. And at that point, I would go and have a look at the error log, because that denotes, that kind of means that there is something in the error log, or there should be in the error log, that ties back to that access log. And then there's loads. There's like 400, which is bad request. There's 401, which is access denied. So you can get a feel for how the users are using the system and how the system is behaving by just looking at these logs. But the first thing to know is where the logs are. So a lot of the times where I see people asking questions for help for coding, they could potentially discover it themselves, or the solution themselves, if they knew where to look. And that is the first challenge. The amount of Facebook groups that I've gone through and I've seen people put in screenshots of code and saying, I don't know what's going on here, but that code doesn't have any kind of indication of the feedback. So my first question is, what's in the logs, right? Yes, hi Heated Pillow. I am certainly working with APIs again. It's it's an API world out there. So feedback loops, it's one of those things that we as developers have to work with and create. And like I said, you can go very narrow. You can put in a particular log entry at a particular point in the flow of your program, or you can go quite wide, and you can go, well, actually, I don't need to know exactly what is in this variable at this precise moment of time, but I can have a wider feedback response that just says, yes, this is done, or this is processed, or these are the amount of requests, or this is the counter of what is in this array. So I'm doing a lot of stuff with Symfony commands, as I've mentioned, and Symfony commands, you run it on the command line. And the only way that you're going to get any form of feedback is if you use the logger, if you use something like Monologue, that will actually spit out output to the command line. So it gives you a prompt, not a prompt, it gives you a response. That is a way of exploring and discovering different, how your system is being used, or how you're using that system. The typical feedback loop that I see is someone doing a var dump and then a die in PHP. So they do a var dump and a die, and in that var dump they have a variable. So they're printing that out, they're var dumping it, they're dumping it to the page, and then they refresh the page, and then they get the output, or a print R. If they do a print pre, and then the print R underneath, and then a die, and then they get the whole sort of formatted, pre-formatted the content of that variable. So that's one feedback way. However, there is certainly a danger in doing that, and that is because if you forget to remove it, publish it up to production, then your users are going to see what's investing in knowledge of the debugger. So I use PHP Storm. It's a fantastic IDE for PHP. I also use PyCharm for Python, both of which have very good ways of debugging code. In PHP Storm, for example, I use something like Xdebug, and that allows me to look at what is inside the variables, what is inside the arrays, and I can put breakpoints in, and I can jump around the code as it's being processed. So there's no manipulation of how that response is actually going to be fulfilled. That I'm not doing any var dumps, I'm not killing the script at a certain point. I'm just going through the debugger. This is one thing that I've had a recent chore with the Lambda stuff, because when you're creating a Lambda function in AWS, then your log files are in CloudWatch. You literally have to go to a website, which is the AWS console, to discover the logs. And it's not necessarily formatted in a way that is very easy to read, as in like to search through, although if you were to use AWS 24/7, then you're just going to get used to it and be better at doing that. But it's very tricky to debug something locally, push it up to AWS without doing some sort of, dare I say, staging tests, that kind of thing. Because with AWS, the actual Lambda script, the function, needs to be in either S3 or it needs to be uploaded in a zip file. So you kind of have to do all your debugging locally, but be able to do that in a way that still has connections to the AWS infrastructure. So it does get a little bit complicated. And the barrier of entry is the feedback loops, or the speed in which the feedback loops come in. Because you want to have something pretty instantaneous. You want to know exactly what is wrong and where it's wrong. And that's another point with the log files. Not only will it give you the error code, it will also give you the location of where that is, so a file path, and it will also give you, hopefully, a line number. So you'll be able to say, yeah, it's blown up at this particular line, at this particular file, and it will also perhaps give you a stack trace. Another thing that I have been working on, as Heated Pillow has mentioned, is an awful lot of APIs. So what I've done is I've created lots of API exceptions, and I've created a way of catching those exceptions and then printing them out to a log file, because the exceptions would come back from the API in JSON format. So you need to sort of pass that out, and you need to make a decision. Where do those logs reside? Is it going to be in the actual API itself, or is it going to be in the client that is calling upon that API? I try and do it in the API itself, because obviously you can have more than one client coming back, but you need to create your client in a way that will handle those kind of negative responses. It's not just going to blow up the page. Something is going to come back and say, we can't fulfill this request at this point of time. But having the ability to digest that feedback is extremely important. Bear with me a minute. I'm just going to grab a drink. So yes, the Angel of Dice has said that the feedback loop is present throughout the cycle. Yes, it is. And as I've mentioned, you can go extremely narrow with feedback, or you can go quite broad. And usually what happens when you're debugging a problem is, first of all, you start broad and then you start narrowing it down. Because when you start narrowing it down, you start honing into the issue that you've come across. So for example, today, I had an issue with the AWS Lambda script, and I wasn't sure whether it was something to do with the NPM installation of certain things that I needed, all the modules, or I wasn't sure whether it was an issue with security and so forth. And so what I ended up doing was writing console.logs in the NPM script to make sure that my variables were actually being populated, because what I was doing was my Symfony command was a post request, and it was requesting in the payload of this request. It was putting in the parameters, the different variables, if you wish, that the Lambda script would be using. Excuse me. So the first thing I did was discover whether or not those were being populated. So I did a console.log on those, and of course those go back off to CloudWatch, so you can then narrow down and discover that yes, they are actually populated. So then let's go and see what is the issue. And of course, with promises, when you're using JavaScript and you're using promises, you can do a catch at the bottom, and that's what I ended up doing, just to catch the actual error. And basically the rest is history. But you end up having to go through these little stages of, has that been set? Has that been set? Has that been set? And unfortunately, with AWS, when you're working with multiple pieces of kit, both your code, their infrastructure, the thing that is going to happen off of the back of that Lambda script, there's all sorts of moving parts. And so what you want to do is isolate where the bug potentially could be. And the smaller you go, the better it is, because you start discarding possible issues. And This is a point that I made at the my software complexities talk at PHP Southwest, and that is that options are the more options you reduce in your system, or in this case the feedback, the more defined and refined you can go, and simplified the problem actually becomes. Because often when we come across complicated problems, when we come across problems that we can't quickly identify, we first go, oh, it must be a complicated problem, and therefore we immediately subconsciously look for a complicated solution to those complicated problems that we think they're complicated. But actually it could just simply be a misconfiguration. It could be a colon out of place. It could be something that just isn't quite right somewhere on down, and it's obviously a complicated problem, and therefore I'm going to be looking at a complicated solution for it. And that's when you start going really broad, and then you start slowly narrowing down your what it is that you're looking for. Now, I believe, don't quote me on this, but I believe it was Frederick Brooks who said that the system, I'm going to completely misquote this now, but basically what I'm trying to say is the system will only tell you what you've asked it to tell you. Right, so if you have no concept of the logging, if you don't know at all where the log files are, if you've told it not to log, then you're only going to know exactly what the system tells you. So go to, that could be as little as just going to the web page and refreshing the page. Yes, the website's still up, but you don't know how much disk space is used. You don't know how much memory is being allocated. You don't know all of those kind of infrastructure type stuff, nor do you know that you're getting PHP undefined errors, nor do you know that your users are dropping off when they get to a certain point. So the more knowledge that you can turn on, more feedback loops that you can use, the more the system will tell you what it's actually doing. However, you can go completely the wrong way about this and go, right, let's just turn on all the things. Let's just get so many graphs and charts and just go completely nuts. Let's just have more log output, write more log output in your Symfony commands or your controllers or what have you, or your Python stuff, than actual code, right? So you just get bombarded with information, and that can be quite dangerous because the actual information that you're after gets lost in the noise of all of this stuff. So not only do you need to know how to look for the log files, discover how you can actually get the feedback, how you can manipulate the feedback, but also how to turn the feedback off, right? Because there'll be some crucial metrics that every developer will need to know and identify. But there's all sorts of like subsidiary information that we need to get to, like for example, all the debugging stuff. You're not going to suddenly print out all of your variables every time the page gets refreshed. You're not going to do that. That's just daft. Yeah, bear with me a mo. So the angel of dice, the angel of dice has said, in addition to the console log and loggers, do you find developers do test cases, aka input versus expected results? Right, so testing code, as in creating a functional test, creating an API test, creating a unit test, that is a way of testing expected outcomes. If you don't have something that will say, yes, this is actually a true comparison of what you've expected, then all you're going to do is just assume. You're just going to make an assumption. Yes, the code works because I don't know any different. So yes, I do. From my point of view, I would prefer to write unit tests than to write console logs, to write var dumps and print Rs, to do what I call quick and dirty feedback loops. I say they're dirty. It's just they're not dirty. It's just there is a danger of putting that in production or something daft. And that when you're like, for example, on my typical day, I have like 30 different tabs open in Chrome. I've got like or Safari, whatever I'm using. My PHP Storm, I've got several projects going because each project has a Git repository, and the projects that I'm working on at the moment for these clients, they have different repositories, and I could be in so many different files in each of those projects. I mean, I could be in 10, 15, and there could be 3 projects open. So it's going to be a very easy thing for me to forget if I've got any kind of printing statement going through. Now, one thing you can do, especially for the JavaScript, and I also believe with PHP, is that you can also you can write ways to remove logging from production. So you can use things like your Webpack or whatever takes your fancy in terms of your task runners to remove, minify, uglify your JavaScript and remove all your console logs. You can do a similar thing with PHP as well, but not every project, and I have to take into account that I am a freelancer, so not every project will be set up the same. So don't assume that your environment is exactly the same when you move from one job to the other. And another thing about bugs, with testing bugs, is that so let's say something's in production, and we discover that there is an issue. There's a page that's just falling over, and it's coming back with a 500 error. What I would like to do in the ideal world is I would like to take a snapshot of the database at that point in time, or at the very least, a snapshot of the portion of the database that is being used at that time. I would then like to pull down the code. I would like to pull down any assets that are required. I would basically like to set up my local environment in a way that can mimic whatever this user is getting as an error, as a bug. I would then like to refresh the page or do whatever the user does in order to get that issue. I would then write a series of acceptance tests to say that will fail because they get to that page, they do whatever that user has done, and it fails. But you've written that acceptance test, that failing test, knowing that when that bug is fixed, that acceptance test will pass. And then what I would like to do is drill down and discover the root cause of that issue. And if I can wrap a unit test around that, then brilliant. That means that once I've fixed that issue, both the acceptance test and the unit test, whatever tests that I've actually written to replicate that issue, have passed. And that means the next time I run my unit test suite, I am checking against that issue that I fixed previously. And that is how I would use feedback loops as a way of going forward and making the code more stable. And once you get into that mentality, that headspace of let's replicate these issues locally, let's then fix them, you are then improving as not only as a developer, but you're improving the system. And that is basically the ideal situation. Now, unfortunately, time is never on our side. So it's not a simple case of let's just pull down the database, let's just bring off all the assets, let's just do all sorts of bits and pieces. Sometimes you have to be very rapid. And so when that happens, I like to do what I've just discussed, but in retrospect. So yes, I fixed the issue and I've pushed it up to production. Great. But let's just do a unit test. Let's just do an acceptance test to ensure that never happens again. Because what you're doing when you're writing tests is that you're trying to make the system more stable. And if there is an issue, if there is a bug, then you want to make sure that that never appears again. And so what I like doing with my unit tests and my acceptance tests is in PHP, for example, I will assign them a particular group. So maybe it would be, I don't know, bug-165, whatever is in the Jira ticket or whatever ticket that has come my way. That means that in the command line, I use codeception. So I can use php bin and then codesep and then run -g, and then I put in the designated group that I want to run. And that means it'll only run that specific unit test. It's not having to go through the whole suite. So that's bugs, but we can also discover feedback loops in other things, such as performance. So I've talked before about the various places I've worked for before, one of which was a very high traffic web hosting company, extremely high traffic. And what we did on a regular basis is we were able to monitor and measure and time the requests going through. And what we ended up with is a series of categories of web pages or processes that were taking a next threshold. And we did that on an iterative process. Sometimes when you fixed something to do with performance, you had a very overarching effect on the other requests, that was looping through and doing all sorts of calls that was blocking up all the other bits and pieces. So maybe you could go in there and alter that, and that would have a knock-on effect because that code was being called in various different places, and therefore you would have an overarching positive impact to that. But without knowing the performance, we would never get into that process. And what we ended up doing, because some people were saying, look, this is slow, but and I've dealt with lots of clients where they just say it's slow. I don't know what I can tell you, but it's just slow. But knowing how slow is slow, you kind of need to get some metrics. You kind of need to discover. And what we ended up doing with some of my clients is that we ended up creating graphs, and we were able to monitor that over time. Yes, the Angel of Death said you need the baseline. You do. You need to know what is acceptable, but you need to know what your system is doing. You can't just say, oh, yeah, every page we want to run in a second. You can't say that if you've got thousands of pages doing different things. Because, yes, that's a very nice goal to have, but let's just be realistic and actually get a realistic figure for how much things are taking. And once you get that, you can then start saying, right, let's break this up into categories. And these pages take this amount of time. These pages take that amount of time. These pages are super fast. Perfect. Let's now move this bracket down. Let's just, and what you're also able to do with that feedback is you're able to target things that actually have the highest rate of inefficiency. And also you can marry that metric up to the amount of people that use that. So, for example, you could be doing a project on this, and you could be working for like hours, days, weeks, trying to get the performance on something that is very rarely used. So one of the questions I'll ask to a client is, well, how frequently does this get used? Yes, it's taken a long time to process, but really, is that more of a priority than the other pages that are taking its time? So sort of analyzing the feedback loop, analyzing the actual things that you have in front of you, and you end up getting a broader picture of the system, and you start going, why is that taking such a long time? You end up discovering things that you never thought were actually happening, or you just never knew. And the best ones are the memory leaks, the ones that slowly over time just amount up and up and up and up. The other ones are race conditions. So when you've got two processes working and one's faster than the other, but one is relying on the other one, and that's crazy. But I've had that before, and it was a case of which one do I speed up, which one do I slow down, that kind of craziness. So feedback loops are extremely important, but again, as I reiterate, it is all about being able to assess what your feedback actually is and being able to prioritize that in the best way that you can. I do apologize. I'm having to drink a lot of Earl Grey today because I've had quite a lot of, I think my lunch was like nuts and something, salted nuts or something daft. So I feel like I've got a bag of sand in my mouth. So I do apologize. Earl Grey. I do like it. So I think the best way I can sort of talk about feedback in a sort of a summarized way is that you need to know exactly what the system is doing, but you don't need to know everything it is doing, because once you have all of that information, the important stuff gets lost in the noise. Yes, it's fantastic to have emails to say that your users are being registered, but you don't need to have an email every time someone's registered. What you do need, however, is an email when someone has tried to register and hasn't been able to register. Does that make sense? It's like you don't need to know every small little process that your system is doing, but you do need to know when your system is not behaving in your expected, in the expected way. So having things like thresholds, that's fantastic. So, for example, a client I had a few years ago called me up very late, said the system's crashed. The system's crashed. I don't know why. They got a developer on it, didn't know what was going on, thought that it could be a number of issues, and I was working with this guy, and we were trying all sorts of stuff. I then took a step back, and we agreed to look at the actual infrastructure itself. Maybe that these requests are blowing up at this particular page because of something that is not configured correctly on the server. So we jumped on the server, we SSH'd onto the box, and we did a little bit of digging. So with Linux, you can check out the memory that's being used, you can check out the disk space that's being used, the I/O and all of that stuff. And we discovered that the log files were consuming so much space that it was now beyond swap on the hard drive. And it was just basically, whenever a user hit a particular part of the system, there was so much logging going on that it was just crashing the system. It was slowing it down. So we discovered that the issue was logging. So what we ended up doing is removing all the log files that were like completely ancient, turning on log rotation and tweaking that, and everyone was a winner. But we didn't know that was exactly what was the issue straight away. We had to do a lot of trial and error, and like I said, you have to sort of go broad and then narrow it down. Now we've left that client with the ability to have error reporting turned on. So if the hard drive meets a certain threshold, they're informed about it. And we've also fixed how the logging gets rotated and how the logging gets stored. So don't just assume that logging things is a great idea, because that itself could cause a problem. And that is an example of where your feedback loop causes a problem with another feedback loop. and you end up with a sort of a false positive. It's kind of like certain pages were working, but certain pages weren't working because the memory and the hard drive was having an argument. And so we were like, yeah, but this page is working, but that page isn't working, and it was just nuts. And that took an awful lot of time. And this is a thing with feedback loops. It takes time. It takes time to analyze. As a freelancer, it's very difficult to tell a client how long it's going to take to actually fix something, because straight away you don't know what it is until you actually are able to generate some form of feedback. And I mean, this is where AWS CloudWatch is so fantastic. Or this is where the tailing of the logs is so good. I'm so glad that Docker, for example, have improved the way that they handle log files. So now you can actually do Docker logs and the container name, and you can get whatever is out on standard. I think it's standard error and standard output, which is fantastic. So just knowing where the log files are is such a brilliant step forward as a developer. But like I said, it's not just log files. It's also the ability of using the debugger. It's also the ability of analyzing metrics that are coming back. And it's also the ability to tweak those too. So for example, Google Analytics, there is no point in having Google Analytics on if you are tracking your own IP, right? Because you're going to get false positives. Yes, you've got 100 people today because you've been refreshing the damn page 100 times today. So it's knowing how you can best manage that and configure that to tell you exactly what you need. And it is a bit of an art. It is a bit of a trick. But there's so many different services out there. One I've used before is Status Cake. So Status Cake will tell you when your website is down. It's kind of like a first layer of defense, if you will. So when your site is down, it will tell you via email or text message or whatever they've got up to at the moment, when the thing is down. Also, I mean, I mentioned command line stuff. Let's talk about false positives with that. So when you're doing chaining commands together, you want to ensure that when a command, the first command, let's say you've got 5 commands chained together. When the first command fails, you certainly don't want to be running the second, third, and fourth and fifth command. You want to stop. You want to go, nope, I don't want to run anything else because I've got an error at the first command. So when you're doing like a bash command and then you're doing and then slash and then another command and slash another command and slash, make sure the first one works first before you do any of that stuff. Otherwise, it's just going to try and run through it. And if none of those commands return an error code, an exit status, then it's just going to go on to the next one. I've done that a lot where it's like, oh, it's kind of worked, but only half of it's worked. And that itself can cause several issues, because if the second script is relying on the first script to have succeeded, then you're going to get other errors or some really weird behavior going on. So Angel of Dice has said, when I do my auto tests, the mantra I follow the data, love, debug, step in. Yeah, definitely. The crazy things I've discovered through the debugger by stepping through. When you use a framework, PHP framework or a Python framework, where maybe it's Flask or Django, and you're using all sorts of things like SQL Alchemy, or if you're a JavaScript developer, you'll be using perhaps a lot of NPM modules. You're using the debugger on that kind of thing. It's very interesting to follow that and just go down the rabbit hole of the code and find out what exactly is actually being called and when. Because you yourself are going to get more of an insight of how the system actually works. A lot of the time, we just download our frameworks and go, yes, fine, it works. And, I'm just going to hope and accept that everything the framework has said it can do, but I'm just not going to bother looking into the framework. but by doing the step through and actually jumping through different various breakpoints and actually going into the calling code, you can actually work out what the framework is trying to achieve. For the JavaScript developers out there, a great thing that I was shown several years ago now was using the web development toolbar in Firefox, and I believe you can do the same in Chrome. And you can probably, I haven't tried it yet, but you can probably do it in other browsers. I have played with it in Safari. And what I'm talking about here, I'm going off on a tangent now. What I'm talking about here is using the JavaScript debugger in the web development toolbar. And what you can do is set up various breakpoints and various watches and all of that good stuff in the JavaScript debugger in your browser. And what you end up doing is you refresh the page to assign all of those things, and then it runs through the code, and you can step through it line by line using the debugger. And it is the debugger, the web development toolbar is such a good mechanism. It's such a good thing that JavaScript developers can use. And a lot of the time I've seen various JavaScript developers who just don't use that. Because they're not aware of it. But when they are aware of it, it changes how they develop. It changes how they code. No longer are they just doing a console.log and refreshing the page and going, yes, that value's changed. They're actually stepping through the code using the developer tool. I think it's the developer tools or toolbar, whatever browser you're using will have it. I think F12 is for Firefox. There's certainly one for Safari as well. It is fantastic because you can, like I said, you can use that as a way of stepping through the code, stepping through your application in JavaScript, and it will tell you the error at that particular point. So that is how I would definitely debug on the front end. Yes, so basically that is my feedback loops talk. I should say that this has been inspired. This ramble, this rant has been inspired by a commenter in last week's talk that I was doing, and that was I think the fellow was called Luki10, and he asked me a question. I was talking about clean coding, and he asked me a question about how do you improve as a coder in terms of how do you write cleaner code if you are only the one person writing the code for the company, if you are on your own. And it threw me a little bit because, I mean, that was such a good question. And I answered with the response of, well, you want to try and be around other developers. You want to try and attach yourself to communities like user groups and all of that stuff. But actually, there is a mechanism that you can improve yourself as a developer by writing cleaner code, and that is feedback loops. So there's all sorts of tools that one can use and install in their IDE that sniffs out bad coding styles. They call it a code sniffer. And your IDE will be able to give you some feedback on your particular coding style. It might give you a red line if there's an error. It might give you, like with PHP Storm, for example, I use the Symfony code coding standards, which has a portion of PSR attached to it, which is fantastic. And you can obviously use the PSR stuff as well. And you install the code sniffer, and it will analyze your code, and it will tell you that your braces are, your braces need to be on a different line. It tells you that you're using you've got your spaces in the wrong way. It'll tell you that you're concatenating things wrong. It will just basically nag you to be a better developer. And you can go one step further and you can actually write some rules in your build pipeline, however you're building your thing, to analyze the code that you've committed against these rules, these code smells that they call it, and it will prevent you from committing any work to your code thing if you've caused this code smell. And it's fantastic. You are basically being nagged. You are being nagged and you're being told that your code is smells funny. And this is the same. You get this with PyCharm. You get this with PHP Storm. You can get this with JavaScript editors as well, where you are trying to write cleaner code in the sense that the code adheres to certain standards, certain agreed upon standards. Maybe it's PSR, that kind of thing. Although I should say that the cleaner code talk that I did last week, we go into more depth about the what clean code actually means, because clean code doesn't just mean syntax and how the syntax is lined up. It means, actually how you're creating code and how you're using code. But anyway, if you want to watch that, that's on the How to Code Well .net website, or if you're a subscriber here, just watch the previous live stream. But anyway, guys, thank you ever so much for watching. I'm going to leave you now. I've taken up far too much of your time. Thank you ever so much for watching. Happy coding, everyone, and I'll be here again next Wednesday. Thank you ever so much. Cheers. Bye.